Lesson 81 of Course 3 is looking at central angles and arcs. If we're talking about central angles, we're talking about circles. So the goal is to be able to divide a circle into equal sectors, which is just another fancy name for sections, by finding the measure of each sector's central angle and relate the measure of a central angle to the portion of the circumference and area it intercepts. This type of lesson definitely needs a protractor and a compass because we're going to be looking at those circles and being able to look at the degrees. Now, a central angle is talking about having a vertex in the center of the circle. Okay, center of the circle, we have a central angle. Okay. An arc is a portion of the circle intercepted by a central angle. So let's say I have an angle that goes from the center of the circle up this way, right, up this way, and let's say it ends at about here. Well, that would mean that this arc from here to here is what is being intercepted by that central angle. Now, we can define that arc in a couple different ways. One, if it is less than half of the circle, which what I just drew is just less than half the circle, we call that a minor arc. If, however, I was actually thinking about this angle that goes from here all the way to here, we would call this all the way around here a major arc because it is more than half of the circle. So minor arc, we just define as less than half the circle, okay, from A to B, this small part here. Whereas if we went A to, let's say we have a point C, all the way back to B, this larger part right here, we call that a major arc. Okay, so we can define things based on how big they are. Now, if we just look and say, all right, we can define them by how big they are, we can also say that the minor arc and major arc have measures. So if we have that same one here, but go just straight out here, we would say that this minor arc from A to B has a measure of 90 degrees. Whereas the major arc from A to B has a measure of, well, 360 degrees is in a circle, minus this original 90, so all the way around here, all those 90s together, it would be 270 degrees. So our minor arc there is 90 degrees, whereas our major arc is 270. So when we are drawing a circle, all right, you use your compass to draw a circle, and then we need to divide it into equal thirds. Well, if we think about a circle having 360 degrees, we would say that 360 degrees divided into thirds means that each one needs to have 120 degrees. Well, we can do that using our protractor. We start with our center and put a line, a radius, okay, to the outside portion of our circle. Now let me draw that again because our board just went funky for a second. So 120 degrees to our center. Now let's use that protractor. So let's see, I have a protractor on my board. Let's see if I can use it here. I can. So let's see if I can turn it. There we go. And let's turn it around. I should be able to turn it, but it's not letting me. There we go. So we need to take our protractor and line it up with our center. And then we can take it and line it up with the edge of our protractor. Well, if we need 120 degrees, we can look here and say my line starts me at 0 right here, at 0. Okay, let's line it up again. And it goes all the way to 120. So from here, we need to go all the way around to 120. Well, that's 110. We have 120 at about there. Okay, so we would take our protractor, line it up, put a dot, and then we can put a line to that dot. Now let's do it again, but we have to rotate our protractor again. Ooh, that's special. Okay, we need to line it up with the dot. We need to spin it around. Okay, spin it around so that it lines up with our new line. Okay, actually let's spin it this way so that we can continue on. So we line it up with our center dot, line it up with our line, and then we go from 0, right here, 0 degrees on this line, all the way around to 120 right here. Now let me get this a little smaller so I can make my dot 120 right about there. I take my protractor away, and I can now draw my line. In theory, if we did this perfectly, which we should be able to do it perfectly with a protractor, I should be able to line this up, spin this around, and see that from here to here we have 120 degrees, which we do. We do have 120 degrees right there. Pretty cool. We just divided that circle into thirds with 120 degrees in each. Okay, now let's say instead of doing it into thirds, we want to do it into fifths. Well, if we take 360 and we want to divide it into fifths, that means that each one of those is 72 degrees. So once again, we put our center, we put our line, and we get our protractor. Let's see if I can do it a little better this time. I'm learning just like you. So I'm going to make my protractor just a little bit smaller. Okay. Now I put it on the center line. I need to line it up, okay, with my protractor. And then I'm going to look and say, well, from 0, okay, from 0, all where that line is, to 72. Okay, we have 60 and we have 72 right about there. So I move my protractor and I'm going to make my line. Okay, make my line from here to there. And then we do it again. Line up my protractor with my dot. Rotate my protractor so it's in line. And from 0 to 72. Okay, 0, 10, 20, 30, 40, 50, 60, 72 is going to be about there. Move my protractor and draw a line. We continue this all the way around and we will get perfect fifths of our circle. Okay, line the dot, the center up, line up the line, and then find your degrees 0 to whatever you're looking for, in this case 72. Now let's look at this one. This goes back to defining our different angles. We say that we have this game that is being played on the blacktop, and this is what it looks like. Okay, it has two intersecting lines, two intersecting diameters. All we are given is that this angle right here is 50 degrees. Well, knowing what we know about angles, we know that this one across, or opposite angle, also call it vertical angle, is congruent, which means that it has the same amount of degrees. We also know, if we look at just half of the circle, we know a straight line has to be 180 degrees. So if 50 of those degrees are taken up right there, that means that there's only 130 degrees left for that part. Okay, same thing up here, 130 degrees. All right, so we can do central angles in the morning. Okay, so we look at our central angles and we're able to find all of the different measures. Okay, now comes a little bit more about those minor arcs and major arcs. Okay, especially when we're looking at if we have a circumference and an area of the circle. So first of all, we have a minor arc AB. From here to here, remember minor arc is just less than half of the circle, whereas if we go from this A all the way around to this B, that is a major arc AB. Now we can define this using degree measures by saying the minor arc AB is 90 degrees, whereas the major arc AB is 270 degrees. Our minor arcs and major arcs, if we have all of those together, they should add up to 360 degrees. Now let's say that we're looking at the circumference, and say we have a radius of 3 centimeters here. Well, when we're looking at the circumference of a circle, we know that is pi times diameter. But we only have the radius, so if we were to extend this, have another 3, that tells us that the diameter is 6. So we can multiply it by pi and say, sorry about that, our circumference is 6 times 3.14. And we can multiply that out, say 3.14 times 6, we get 24, 6 plus 2 is 8, 6 times 3 is 18, and we see that the entire circumference is 18.84. Well, what if we just wanted part of the circumference, maybe just the minor arc part of the circumference? Well, since we know how many degrees the minor arc is, we can take that circumference of 18.84 and we can just take the portion that we want. Since this is 90 degrees, that's just a fourth of the circle. Well, I'm going to take a fourth of my 18.84. So if I do that, I'm just going to divide this by 4. 4 goes into 18 4 times. Okay, and we get 16 with 2 left over. Bring down that 8. 4 goes into 28. Well, 7 times. Okay, and then we're going to have a 0, bring down a 4, and we have 1. Which means that the circumference of just this minor arc, just the minor arc distance, okay, is 4.71. Which means if we want the major arc, there's a couple ways to do it. We can say, well, if that's 1/4, then this entire thing is 3/4 of the entire circle. So we can take our 4.71, multiply it by 3, or we can take my 18.84, my entire circumference, and subtract 4.71. We should get a our major arc distance of 14.13. That should be our major arc distance. Okay? Now we can do it with circumference, but we can also do it with area. So let's say we have this one right here with 60 degrees in that minor arc. That means that that is 1/6 of the circle, and the other part is 5/6 of the circle. Okay, well, as we can see, we have 6 centimeters as our radius, and let's do this one and keep it in terms of pi. Well, if we want the area of each piece, we need to know the area of the entire thing, which is pi r squared, r standing for radius. So we can plug in what we know. Okay, let's get us a little bit more room. Okay, so let's find the area of the whole thing in terms of pi. So area is going to be pi times, sorry about that. Okay, we're going to do pi times radius squared, which is 6 squared. So we get an area of 36 pi. Well, let's say I just want my minor arc of AD. That means that I just want 1/6 of means multiplication, 36 pi. which means that I actually just have a portion that is 6 pi centimeters squared. That's just this part right here, 6 pi centimeters squared. That's the area of that piece. But if we want my major arc of AD, that's this big 5/6, we would take 5/6 times 36 pi, because that's the whole area, and see that we get 30 pi centimeters squared for that larger part. That 5/6 of the circle is 30 pi. Okay, so we can do just part of the circle to figure out the area. Okay, it's all based on how many degrees we have in the minor arcs and the major arcs. Okay. Hopefully this was helpful for your homework and studying. If you have questions, let me know.